So I don't think I need to really introduce our next speaker because I think all of you guys in the room have heard of TinyML, which has been a recurring theme across this conference. But the only thing I would say about him is that today he came here braving traffic with the coolest ride. Please welcome Pete Warden.
Okay, thanks so much, Kate. I'm here to talk about not what TinyML is, but why it's important, and really why we're talking about it. What is it good for? What are the concrete use cases that make machine learning on these kind of embedded devices really important? And to explain that, I'm going to start off with machine learning on mobile and machine learning in general. So I really liked one of the phrases, I think, from Jem at the keynote yesterday, where he said, machine learning is kind of like a sonic screwdriver from Doctor Who. It's this incredibly versatile and useful tool for solving all sorts of problems. Especially problems that were very hard to solve before around very messy, chaotic data. And machine learning is being used in all sorts of places already. And specifically on phones, TensorFlow Lite for mobile is being used on over 3 billion devices in production. There are all sorts of applications that it's being used for that rely on machine learning. Almost any application you can think of is going to have some kind of machine learning happening somewhere, quite often on device. And we have the examples of music identification, which is one of my favorite things I'm going to talk about a little bit more. On the embedded side, where you actually can just have your pixel sitting out on the table on the lock screen, and it will be listening and actually identify different kinds of music that are playing. It's used for things like the camera, so doing night sight photography, as well as all sorts of other camera modes, actually rely on deep learning to implement their features. Even for things you might not think would involve machine learning, like extending the Android phone's battery life, is actually powered by some really clever machine learning to figure out which apps you're likely to use again and which you aren't, so it can actually shut off apps that you aren't likely to be opening up anytime soon and have a significant impact on extending battery life. And just to sort of back that up, here are just some of the clients that are using TensorFlow Lite on the phone. And so why am I talking about this? 2 or 3 years ago, I was at conferences like this trying to convince people that machine learning on phones was real. My pitch was, hey, this is actually something that's significant. This is going to result in real applications. It's useful for all sorts of things. And really, if you're writing anything where you're having to kind of draw up your own hand-drawn rules and you're having to kind of pick thresholds and do complex logic, there's a very good chance that being able to learn the rules from data is going to be a better way to approach this. And specifically, running this stuff on device is not just kind of an optimization compared to running stuff on the cloud. It actually enables things that you just can't do if you're reliant on running on the cloud. There are things like interactivity and just pure power usage that preclude you from using cloud APIs. So doing this stuff on the phone was really important. And by and large, these things that I was pushing have actually proven to be true. And that's not because I'm super smart or any kind of profit. It's purely because I'm sitting, and my team is sitting in a really interesting position because we're providing infrastructure to people who want to build machine learning applications. And that means that when people have applications they want to build that they can see are almost possible, they come to us and they ask us, hey, can we build this? And a lot of the time we can say yes, and we can sort of point them to ways to do this. But when we can't, I really like to try and remember those unmet needs and try and use them to prioritize not only what we're working on, but what we're asking our partners at places like Arm to focus on as well. And I really like to say, I would love to say no less often. So that's really where the mobile use cases were, coming from. The sort of what I was asking a couple of years ago, 2 or 3 years ago, was really coming from this unmet needs from all of these application developers who actually wanted to build stuff. I knew that if we could provide solutions that would meet these needs, people would be using them. And that's where I'm coming from with TinyML. We're in the same position that we were a few years ago with mobile. We have a whole bunch of applications that if we just had the right technology combinations would be shipping right now, that people would love to use. And to explain that a bit more, I'm just going to cover the basics of what TinyML is. Really for TinyML, why it's different from the sort of phone-based machine learning I've been talking about up till now is that it's designed to run always on in situations where you can't be changing batteries or recharging something manually, and you can't have something wired in to mains power. So what that boils down to is you need something that can run either on batteries for years, so you don't need any human intervention, or even on something like energy harvesting. And in practical terms, that means you want something that's running on an average of 1 milliwatt or less. And some interesting things actually flow out of that constraint. It means that you really can't be connected by radio for the majority of the time. Even low power, very short range radio is still using tens to hundreds of milliwatts. So you can only afford to have the radio on for very, very short bursts if you want to stay within that power budget. And it means that you're also likely to be running on something that only has tens or maybe hundreds of kilobytes of memory. So you're running in an extremely constrained resource environment. So it's very different from kind of the phone or even something like the Raspberry Pi, where you're running on a pretty familiar sort of like Linux-esque environment where you have, at the very least, tens or hundreds of megabytes to play with. So you have a really interesting set of challenges, but if you solve these challenges, these devices can be incredibly cheap. The average selling point of 32-bit microcontrollers is heading down towards like 50 cents a unit at scale. So you have this potential, if you can hit these targets, to actually have something that can scale up to trillions and trillions of devices. So it's a really exciting opportunity. So what are the big challenges? Really, one of the biggest challenges we face is the same one that we had a few years ago with mobile, in that we don't have awesome killer apps to point to. We don't have that many existing applications that we can say, hey, look, this is why you should build the software and the hardware that you need to support these embedded ML applications. But we are starting to see some things emerging, and based on the kind of demands and the things that people are asking us for, I want to make some predictions about the areas that things are going to be emerging in. Some of the fields and some of the applications that I'm expecting will be really pushing the whole field of embedded ML forward over the next year or two. And really starting off with one of the most mature areas, when I joined Google back in 2014, I discovered that the OK Google team was actually using a neural network that was only 13 kilobytes in size to run on DSP and actually listen out for somebody saying the wake word. And the reason it had to be so small was that the only way that they could actually be running while the lock screen was on was if they were running on some kind of always-on processor, some kind of DSP that's in most Android phones these days. So it meant they had to deal with these TinyML embedded constraints a long time before almost anybody else. So these days, whenever you have any kind of voice interface, you almost always have a wake word system that's running at very low power. Even if you're using something that's plugged into the wall, there's a good chance that for energy-saving purposes, you might be running a DSP to avoid kind of draining power all the time. So this is a very, very mature area compared to everything else, at least. And we do have some examples in the TensorFlow Lite micro code base that you can look at to help you sort of build these simple wake word systems. So we're expecting that this is going to continue to be an important use case. But where I'm really excited about seeing this going is doing more than just the wake word on an embedded device. And something that gives kind of a flavor of where things are going is the launch earlier this year of a full speech recognition system that actually runs as well as the cloud-based system, but runs locally on a Pixel phone and fits within 80 megabytes. Now, that's clearly larger than existing embedded systems, but the fact that we can have this full quality speech recognition system running locally on a phone on an ARM A-series processor within a few tens of megabytes shows that being able to do high quality speech recognition on embedded devices is not a crazy pipe dream. It's something that we really should be thinking about and aiming for. And one of my dreams is if we could have a 50-cent chip that did voice recognition and ran for a year on a coin battery. Think of all the switches and buttons and components that you could actually replace in consumer devices with that sort of really easy to use black box kind of component. You wouldn't even need to know necessarily that there was any machine learning happening inside it. If you could actually package something up so that it was usable, we could really bring voice interfaces to the masses. Another thing that I found really interesting is voice interfaces and vision signals. So one of the most obvious ones is, are you looking at a device? Is that a really useful signal to help you understand, especially when you have dozens or hundreds of these devices in your home or in your workplace or in your environment, they want to know which one you're actually talking to. So being able to use the same sort of cues that we use as people to tell if somebody is talking to us seems like it could be really important for building voice interfaces and building these always-on embedded systems. I'm going to take my life in my hands and see if we can play a video. Let's.
I'm not a fan of flying. Hate being on planes. In general, there's so many noises. You know what I mean? I won't flush the toilet on an airplane because of the noise. Like, it scares me. You go, you hit flush.
So this is two people talking over each other.
For 5 seconds, then out of nowhere, boom! Boom! Oh my God!
And we're just using vision signals to tell which person is talking and extract their track. So you can see the other person is still talking, but we're only extracting the information from the person we care about. And to me, that is kind of magical because we're doing this with just a single microphone and no advanced kind of audio processing. This is just using the vision signals and doing something a bit like lip reading in a neural network manner to actually pull out the information from kind of the cocktail party of people talking of just the person that you care about. And this is kind of the magic of using neural networks for this kind of stuff, is that if you're using neural networks for one thing, it's comparatively easy to add in more information to a model and kind of extend the model in ways that really haven't been possible with traditional image and audio and signal processing techniques. So I mentioned the pixel music detection, which I really feel is this fascinating use case for me because it's a whole new way that computers are able to help us. We don't actually have to explicitly ask the phone to do something for us. It's just kind of sitting there in the background and is providing useful information. And I don't know what all of the applications are going to be, but I think that there's going to be a whole bunch of other useful things that we can actually do using smartphones and using those always-on processors, which are very often sort of, Cortex-M style, microcontrollers running in just a few milliwatts. Another area that I think is really interesting and is going to have a high impact, but may take a reasonably long time to actually come about is predictive maintenance, actually trying to do things in industrial contexts. And Shoreline IoT, a great startup which have done some really, really interesting work around that using Ambic Cortex-M4 chips, which are really, really low power devices. They can run sort of 1 milliwatt or below at 48 megahertz with all of the nice stuff that you get with Cortex-M4 DSP instructions. And so they have this really interesting solution that sits on top of motors. You can just kind of peel and stick this sensor, and it will last for up to 5 years just on the same pair of batteries. And one of the things that's interesting about the industrial environments that I didn't realize until I started delving in was that it's often surprisingly hard to actually get mains power, even when you are in an industrial factory environment, because attaching new devices to power is not as easy as just plugging something in your home. So I think this is going to be an extremely high impact use case. One of the big challenges is that the replacement cycle for a lot of these industrial machines is extremely long, so you have to be fairly innovative and kind of fast-moving, figuring out how you can actually get applications and products into these environments without having to wait sort of 5 years for them to replace whatever piece of machinery you care about. On the other end of the spectrum, toys are a massive amount of fun with machine learning. And I think, we did the workshop with Arduino where we were showing kind of how you could actually recognize gestures using the accelerometer. We have a demo, we're going to be doing a workshop this afternoon with SparkFun, showing how you can use a magic wand, and how you can actually have a magic wand that recognizes different gestures using, again, an Ambit Cortex-M4 chip. And what's really cool about toys is they have this incredibly fast experimentation and iteration cycle. And I'm like, fingers crossed, not this holiday season, but next holiday season, I'm really hoping that there are a whole bunch of, sort of magic wands and all sorts of other devices that we could never have thought of coming out using TensorFlow Lite Micro, because there's so much innovation in that space. Now, it doesn't have the same obvious impact in terms of, worldwide, sort of improvement in any kind of important metrics that things like the environment or medical or industrial stuff have. But I love the idea of kids actually having some fun thanks to machine learning. Automotive is a lot like some of the industrial use cases in that it's a slower moving environment, but it can have a very big impact. Interestingly, power tends to drive the automotive use cases less than the reliability and the unit cost that you get from having an embedded device. One area that I've actually had some really interesting conversations already at this conference about is environmental. And this is another area where there's a massive amount of innovation. There were some really, really fascinating, high-impact problems. The biggest problem is that there's often very little funding, and trying to attract people with the right expertise to work with nonprofits can be extremely challenging. But I'm excited about working with groups like wildlabs.net, who are a great network for bringing together a lot of people doing really cool stuff around environmental monitoring and camera traps and things like that. And I'm looking forward to seeing a lot of more use cases coming up out of this. Building automation, the classic example that I always use, because I'm usually sitting in a Google meeting room, is that the lights will turn off if you don't move enough. So you can tell when a meeting's getting really boring because the lights go down, and then everybody has to sort of stand up and do calisthenics to wake things up. We should be able to tell when people are in rooms just using very simple low-power vision sensors. And we actually have an example, a code sample with TensorFlow Lite Micro for doing this. And I actually hadn't seen the, was it Neighborly, the example that Massimo was showing, where it knocks on the wall of your neighbors after learning what noises you hate. But that I thought was awesome. And I guess you could count that as building automation if you really want to stretch it. There's also a lot of really, really interesting use cases in the medical world. It's fascinating because there are so many problems that you can actually solve using on-device machine learning. It's obviously a highly regulated area, which means that getting some of these things into people's hands can take a long time. But if you can, I think that there's a really big impact possible. So I've covered some of the places where we see innovation and we see applications happening, but really the reason I'm here is that you are the people who will be building these applications. Like, we're providing the infrastructure, we're hopefully providing some documentation and kind of pointing people in the right direction if we can, but it's people like you in the audience who have the interesting problems and have the interesting domains that you're trying to actually build products in. So I want to hear from you. I want to hear what stuff you want to build, what things you're running into, and really how we can help. And my email is petewarden@google.com. I would love to hear from anybody who's trying to build machine learning embedded applications and really hear how we can help. And what is really, really cool is how fast this world is growing. There's already 250 billion of these embedded devices out there and active at the moment. That number is growing, or the number sold is growing by 20% every year, which is pretty incredible considering smartphone and even internet users numbers are growing at very, very low numbers or not even growing at all. So this is a space where the opportunities are massive. And we really have a chance to solve so many interesting problems across all of these different spaces. So thanks so much for your time. I really look forward to hearing from you and seeing what you can build.